Going to walk you through some vocabulary really quickly to get you familiar with some of the terminology we may be using. First of all, you need to know what an equation is. Two expressions set equal to each other. So you can see your examples right here below that vocabulary term. 3x equals 9, 2x plus 5 equals 12. And your job then would be to go and find what value for that variable x would allow for this to be equal. The solution of an equation, again, is the number that you can plug in for that variable to make the equation true. And then we also need to be familiar with inverse operations. Inverse operations are your opposite operations, or the operations in math that undo each other. So addition to subtraction, and of course then multiplication and division are opposites of each other. So we'll be using these to help us solve equations because we have to work backwards. Let's take a look then at a couple of problems that you'll be asked to do. First of which, substituting in a value to see if it's actually the solution. So in other words, they're giving us this equation, 3x equals 15. And this time, instead of us solving for x, they're actually giving us a value and asking for us to see if it's actually true. So what you will do is take 5 in this case, which is right here, and substitute it in for your variable. Now this means 3 times x. This portion of your equation right there means 3 times x. You can't just put the 5 there and say 35. That's not how this works. You have to actually take the 5 and substitute it into the problem. I recommend using parentheses as I've done here. And the reason why is because that separates the portion of the problem that you've put in. Later on you'll see that that has some benefits as you move forward more in math. But right now we can see if we do 3 times 5 that we do actually get 15. So both sides of our equation give us 15, which means that this is a solution. The next example is the same type of problem. This time it involves subtraction. We're going to take the value 9, substitute it in for x to see if that would give us 14. So in substituting it in, we see we get 9 minus 5 equals 14. Right? And of course 9 minus 5, however, gives us 4. And 4 does not equal 14, which means 9 would not be a solution in this case. Alright, so let's take a look at some word problems here involving writing equations. Many times they're going to want you to solve them as well, but getting them set up appropriately is going to be one of the key aspects of equations. So in this particular problem, Coach Pryor bought 32 soccer balls for the new season. This gives the team a total of 88 soccer balls. How many did they have before he bought the new set of balls? So what we have to figure out is what to do with our variable, what operation. Well, of course, if you're trying to combine the number of balls that we had to begin with, that's what our variable is, number of original balls, with the newly purchased balls, which was 32, then that basically becomes addition, because you're going to add your original set to the newly bought set. So that's going to be x plus 32, which gives us the grand total of 88. Okay, so in this case, to solve, that's where your inverse operations come in. To solve this problem, you have to do the inverse of adding 32 to get your variable isolated. So in this case, we're actually going to subtract 32 to both sides, and in doing that, we'll get our solution. 32 and negative 32 cancel away to 0. X plus 0 is x. And 88 minus 32, 8 minus 2 is 6, and 8 minus 3 is 5. So you can see originally we already had 56. All right, the next one. Tina earns $12 per hour babysitting. Write an equation and solve for how many hours she must work to make $288. Well, in this case, one of the key terms here is per. That's a word that we typically will use for multiplication. So we're going to set up our equation in terms of that multiplication. X is going to represent the hours, because they're asking for how many hours. So that's the hours she's going to work. So we're going to take the $12 that she makes per hour and set that equal to 288, because we want to know how many times 12, how many hours times 12 will give us 288. Now again, we have to use inverse operations here. We have multiplication in 12 times x, and the inverse of that is division. So we're going to divide both sides by 12, which makes this 12 divided by 12 becomes 1. And 1 times x leaves us with simply x over there on the left side of our equation, which is what we want. So now we need to go off to the side and do a little scratch work to figure out what 288 divided by 12 is. 12 goes into 28 2 times. Multiplying will give us 24. We subtract there and we end up with 4. Bring down your 8, and 12 goes into 48 4 times. So you see then that we end up with a value of 24 for the number of hours she will need to work. All right, the next example. The 8th grade students at Bay Creek Middle School must be split into groups of 6 for a relay race. If there are 54 groups of 6, how many students are in the 8th grade at Bay Creek? Well, again, in this case, one of the key terms here is being split into groups. It's actually a key phrase. When we use division, that's actually what we're doing. We're splitting things into even groups. So that tells us that our original problem would have been division. What we don't know is how many students that we're dividing. So our variable here in this case is the students, the total number of students. So we will take that variable, divide it by 6, because we're looking for 6 even groups, which actually came out to 54. Okay. However, again, we don't know how many total students we began with. So the inverse, we're looking at a division here, x divided by 6. The inverse of division will be multiplication. So we're going to multiply both sides here by 6, because that's what we're dividing by. We multiply both sides by 6. And you can see then off to the side, we're going to multiply 54 times 6 to give us our solution. And we get 6 times 4 is 24, carry the 2. 6 times 5 is 30, plus the 2 is 324. So 324 students that we divided up into 54 equal groups of 6. All right, so let's just take a look at some straight equations, no word problems involved here. And again, what I want you to keep in mind as you work through these, or as you watch me work through them, is think about why I'm using what operations. So again, when you look at a problem like x plus 1/2 equals 14, you have to undo that addition. So how you will undo that addition is with the inverse, which is subtraction. So we're going to subtract 1/2 to both sides here. And again, we're subtracting 1/2 to isolate our variable, because that cancels away to 0. All right, and by subtracting 1/2, that will eventually give us our solution. So off to the side, we need to do that. And that's going to be 14 over 1 minus 1 over 2. And again, if you've forgotten how to subtract fractions, you need a common denominator. Our common denominator here will be 2, so we need to multiply the denominator and the numerator by 2. So that's going to give us 28 over 2 minus 1 over 2. And once we get that set up, we can go ahead and subtract our numerators. Remember, you subtract the numerators only. So you're going to end up with 27 over 2. And again, at this point, it's dependent on what your teacher wants you to do. If you've been working with mixed numbers, you'll have to divide to figure out what that would be as a mixed number. So that's 2 into 27. It goes into itself once. Bring down the 7. And it goes into the 7 3 times. And that's going to leave 1 left over. So when you're setting up your mixed number, then that leftover or remainder value becomes your numerator. The original dividing number there is going to be your denominator. So you end up with 13 and 1/2 as your answer there. Of course, if your teacher wants you to leave it improper, you can always do that, which would have just simply been 27 over 2. Right, your next example will involve some decimals. All right, so the first thing we'll look at here, what I want you to notice is that 23.5 is a positive value. Okay, we're not going to automatically add 23.5 because we see this subtraction sign. That would actually be wrong. You have to think of the inverse. What would the inverse of a positive value be? Well, that would be a negative value. Negative values also mean subtraction. So your first step here would be to subtract 23.5 to both sides of your equation. because again, what you do to one side, you have to do to the other. All right, so in doing that, we cancel away our 23.5. Now the key to this one is making sure that you bring down that minus sign, because what that minus sign is actually saying is that our x is a negative. You can't just leave that up there. That can be a little tricky. And then of course we need to subtract here. So 6 minus 5 is going to be 1. Bring that decimal straight down. 8 minus 3 is 5. And 5 minus 2 is 3. So you see, at this point, we have negative x equals 35.1. Well, you might think that's your answer, but not quite, because remember, we want to know what x is, not negative x. And actually, what we found here is the opposite of our answer. So if you can remember to just simply change the sign, you can do that. Algebraically, however, what you would do is divide both sides by -1, because in doing so, that eliminates the negative sign from the x, and you'll see that it actually changes the sign of the value that was there originally to a negative in this case. So your answer ends up being negative 35.1. Right, a couple more here, just giving you different variations of these equations that you'll see. And you'll notice the majority of them are just one step. These are really just considered one-step equations. All right, so this is actually a problem I'm going to have to rewrite. X over 5 equals 13.6, because I need a little bit more room here. And this, again, when you see x over 5, I know it looks like a fraction, but what you have to keep in mind is that fractions are division. So this is x divided by 5. So what that means, the inverse then, to solve it, we would use multiplication, because multiplication is the inverse of that division. So we're going to multiply both sides by 5, which again eliminates your denominator, cancels that out to 1. X, which is what we wanted. Okay, and off to the side, we're going to do a little multiplication. 13.6 times 5. All right, so again, if you've forgotten to multiply decimals, you just multiply the numbers together at first. So 5 times 6 is 30. Carry the 3. 5 times 3 is 15, plus 3 is 18. Carry the 1. 5 times 1 is 5, plus 1 is 6. Then at the end, you look and see how many values are behind decimal, okay, how many decimal places there are, and that's just going to be one value. So we move our decimal one place, which would end up giving us 68. So our answer to this one would be 68. All right, one more example here. This time we're looking at a problem involving decimals and multiplication. This is 0.12 or 12/100ths x equals 14.4. Right, so to solve this, we would have to divide both sides, because that's the inverse of that multiplication, by 0.12. Again, what we do to isolate the variable, we have to do to the other side. Keep that in mind. So this will eliminate to 1x. And then off to the side, we need to do a little bit of division of decimals. Right, and it's a good review here as a reminder that we actually don't divide by decimals. We actually divide by whole numbers only, which means we have to move our decimal of the value outside the decimal, or the division sign, excuse me. So we need to make that a whole number. To do that, I'm going to have to move the decimal 2 places to the right in 0.12 to make 12. Okay, and in doing that, I also have to modify what's underneath by moving the decimal the same number of places. So I'm going to end up having to add a 0, and that's going to give me 1,440. Okay, so now I'm really just dividing whole numbers at this point. There's really no decimals left unless I have to add one for my solution. So 12 goes into 14 one time. Put the 1 right above the 4. All right, and then subtracting there, you'll end up with 2. Bring down your 4. 12 goes into 24 2 times. And you get 0 left over. However, you still have one more value, that 0 out there. We can't forget about it, so we still have to continue dividing. 12 goes into 0 0 times, and this will actually work out nice and even for us. So your answer to this one would be 120. Right. Thank you for joining me. It's been a quick tutorial on equations.